This question says write the vector A to C in terms of A and B. So A to C means from A to C. So we need to go from here up to here. Now we can't actually go along this route because it hasn't got a name. We don't know what it's called. So we need to go a different route. We can see that A to B is called A. So the route A to B here is called A. And the route B to C, that's called B. If I went backwards along A to B, if I went from B to A, that'd be a minus A. If I went from C to B, that'd be a minus B. But to go to A to C, I'm going to go from A to B. So I'm going to go A to B, which is an A. And then from B, I'm going to go up to C, which is a B. So A to C is A plus B. Okay, this question says X is a point on B to C, so a point on here, such that B to X, this is X here, B to X is 2 parts, and X to C is another 1 part. So this is 2 parts, this is 1 part. So we can say that B to X is 2 out of 3, 2/3 of the journey, and X to C is 1/3. So B to X is 2/3 of the whole line, B to C, and X to C is 1/3 of it. Okay, so we need to go from A to X. So if there was a part A to this question, the part A would say find B to C in terms of A and B. So let's find B to C first. So from here to here. We can't go up here as it hasn't got a name. So we're going to go B to A, which is backwards along the B. So it's going to be minus B, backwards along the B. And then we're going to go forwards up the A. So minus B plus A. So that's B to C. So now I'm going to go A to X. So A to X is going to be A to B. I'm going to do A to B first. And then I'm going to go from B to X. So A to B, that's our B. And then B to X, that's 2/3 of this journey. So 2/3 of B to C. So 2/3 of B to C. And then we need to simplify this by expanding the bracket. So we're going to have B, and then 2/3 times minus B is minus 2/3 B. And 2/3 times A is 2/3 A. So it's no different saying 2 times A is 2A. It's 2/3. 2/3 times A is 2/3 A. And I've got a whole, take away 2/3 of the B's. So 1 whole, take away 2/3 is 1/3. So I've got 1/3 B and 2/3 A. And that's the answer. Okay, M is the midpoint of A to C. So that's here. And N is the midpoint of B and C, so that's in the middle here. Prove that MN is parallel to AB. So to go from M to N, again, if there was a part A, it will be find A to C. So find A to C in terms of A and B. So A to C, I'm going to go A to B, A to B, and then I'm going to go from B to C. So A to B, this time it's 2A plus B. And B to C, I think that should be there. So that's halfway is called a B, so the other half's also called a B. So B to C is minus B, which is minus 2B's. So A to C is 2A minus a B. So that's A to C. We need to go M to N. So we're going to find M to N. We already know A to B, and then we'll see what parallel means after. So let's go from M to N. So M to N is going to be M to C, and then C to N. So M to C is half of A to C. So half of A to C, and then plus a b. So we expand the bracket, half times 2, that'd be 1. Half times minus b is minus a half b. Minus a half b plus a whole b is plus a half. So plus a half b. Right, so now we've got m to n, this is m to n, and we've got a to b. A to b is 2a plus b. How do we prove they're parallel? So to be parallel, one has to be a multiple of the other one. So is one a multiple of the other one? Well, yes it is. So a to b is equal to 2 lots of mn. So because it's a multiple, because mn is a multiple of ab, or ab is a multiple of mn, but because one is a number times the other one, that means they're parallel. They're going in the same direction. If I went along 2 mn's, I've gone along an ab, so they're going in the same direction. ab is a multiple of mn, therefore mn is parallel to ab. Okay, here's another question. So x is the point on AB such that AX is 1 part, so it's 1 part, and XB is 3 parts, so 3 parts down there. So it's in 4 parts in total. So this is 1/4, and this bit here, the big bit, is 3/4. And then we need to go O to X. We need to prove it's parallel, so a multiple of A plus B. So O to X is going to be there. So to do that, firstly, we need to find A to B. So let's go from A to B first. So we're going to go minus an A down to O, so minus an A, and then plus 3B. That's A to B. And then if I want to go O to X, I'm going to go up O to A, and then I'm going to go from A to X, which is 1/4 of AB. So O to A is an A, plus 1/4 of AB minus A plus 3B. Expand the bracket, so it's minus 1/4 A plus 3/4 B. 1 whole take away 1/4, that's 3/4. Plus 3/4 B. So we can see that that's parallel to AB. AB is 3/4. I mean, yep, A plus B is, this is, O to X is 3/4 of A plus B. So O to X is 3/4 of A plus B. Therefore, OX is parallel to A plus B. Okay, so you can give these 2 questions a go. So see if you can answer 2 questions. Pause the video and give them a go. Okay, so this first one over here. So AX to XB is 1 part to 2 parts. So that means AX is 1/3 of the total, and X to B is 2/3. We need to go from O to X. So firstly we need to know A to B. A to B is minus an A, and then plus 2B. And O to X, that will be O to A, and then 1/3 of A to B. So O to A is an A, and then we've got 1/3 of minus A plus 2B. Expanding the bracket gives us minus 1/3 A plus 2/3 B and a whole take away a third is 2/3, so we've got 2/3 A plus 2/3 B. So O to X is 2/3 of A plus B. Therefore, they're parallel because it's a multiple. It's a multiple of A plus B. It's 2/3 of it, so it's parallel to it. M is the midpoint of A and C. M is the midpoint of A and C here. N is the midpoint of B and C. Prove that MN is parallel to AB. So we need to go from M to N. So we need to know AC first. So let's find AC first. It's 2A minus 2B. So there's a B there and a B there. 2A minus 2B. So what do we need to M to N? M to N is half of A to C. Half of A to C. And then plus C to N, which is a B. Plus C to N. So half of A to C. Half of 2A minus 2B. Plus a B. Half of 2 is just 1. So B. A minus B plus B, and that gives me A. So M to N is just an A. So is it parallel? Yes, it is, because M to N is half of A to B. So therefore, because it's a multiple, it's parallel. So therefore, they are parallel. So two lines are parallel if one's a multiple of the other one.